So now we're going to look at factoring by grouping. Okay? What happens when you have a four-term polynomial and what you must do? Okay? So the last two questions that we just did, there's something that's going to take place that happens with factoring by grouping, and you know that you're doing it right. Okay? And I'll show you that. Let's look at the first question. Here again, is asking you here to factor. Okay? Now, we have here AB plus 9A plus 2B plus 18. Okay? Now, in the process of factoring, you still have to ask yourself, is there a GCF that can be factored out of not just, 3 terms or 2 terms, but is there a GCF that can be factored out of all 4 terms at the same time? No, at the same time. It just can't be just, I'm just saying, well, other than 1. Okay, yeah. Other than 1. And we can put 1 there, but it's not necessary right now. But any other number, no. Okay? Now, the textbook calls it factoring by grouping. I was taught when I used to teach high school, my students used to call it the chop method. It was like whatever way that you want to remember it, it helped. Well, chop method. Well, we take it and we split it in half. We chop it. Okay? And then we're going to cover up the last 2 terms. Look at the first 2 terms. Factor out the GCF, and then tell me what is left over. And what's left over in parentheses. So our GCF is going to be what? A. And what is left over?
B plus 9.
B plus 9. Okay? Remember, if you start off with 2 terms, what's left inside the parentheses, we must have 2 terms.
It must match up as B plus 9.
On the other one, yes. Excuse me. Okay? We're done with that. Look at the last 2 terms. Find the GCF and tell me what is left over. A 2. A positive 2. And then what's left over? B plus 9. Now, at this moment, I've taken away the paper. This looks like what we just did. This time now, you're going to factor out a common binomial.
B plus 9. What is that 9? You divide.
2 divides into 18, 9. Okay. Okay. You want this part, and that was the question asked earlier. These must match. The binomials must match exactly. If they don't match, then we did something wrong with the factoring.
So they have to match.
They have to match, yes. Now, factor out the common binomial. What would that be?
B plus 9.
B plus 9. And then what is left over? A plus 2. That's your answer. Need to move it up some. There we go. All right. I asked myself, is there a GCF that can be factored out of all 4 terms at the same time? We say yes or no. We say no. Let's move on. We have 4 terms. How do we factor a 4-term polynomial? Well, chop it. Group the first 2 terms together. Find the GCF and tell me what is left. 5x And then what is left?
3y.
So if you know that parenthesis part, 3y plus 5, you know that is correct, then you know what the second one is going to look like because they have to match exactly. Okay? Excuse me. What will be the GCF or the last half?
7.
A 7. Positive 7. So you're going to have 3y plus 5. Here again, your binomials need to match, must match. And then our answer, 3y plus 5 times 5x plus 7. Could I have written instead 5x plus 7 times 3y plus 5? Are those the same answers? Yeah. What changed?
Position.
Just the order of it, yeah. But as long as one parenthesis had 3x plus 5, 3y plus 5, and the other one has 5x plus 7, it doesn't matter which order it is in. Okay, it does not. And we're going to get into just a little bit of the factoring trinomials today, the easy ones. And order doesn't matter. All right, here we go. Let's do 2 more of these here. We have 2xy minus 3x minus 6y plus 9. Is there GCF that can be factored out of all 4 terms at the same time? No. How many terms do we see? 4. The method we're going to use, factoring by grouping. So, chop it. Look at the first 2 terms, find the GCF, and factor it out and tell me what is left over. Your GCF can be a number, it can be a variable, it can be both. X. So factor out an X, what do we have? Yes. Now, I like this one because negative. Look at the last half, okay, of this. Okay, remember, even though we're looking at the last half, think of it as a separate part of this question because we want to remember, if you have a negative first term, you want to factor out, you want your GCF to be negative. So, I know it's going to be negative, but negative what? 3. So, a negative 3, and you know what you're going to have left over. When you divide a negative into each of those terms, those signs are going to change, but you're still going to get 2y minus 3. Okay? 2y minus 3 must match. And then what's left over? X minus 3. Okay? Any questions with this one? We're going to do one more of this factor by grouping. Okay? We have here 6xy minus 4x minus 3y plus 2. So give you a 30-second head start with this one. Okay, here we go. Chop it. First 2 terms, factor out the GCF, which would be 2x. And we have, what, 3y And then the second one, we're going to factor out alright, so 3y minus 2 times 2x minus 1. Okay, there we go. That wasn't too bad, was it?
It's hard.
Let's look at this last one. The area of the material needed to manufacture a tin can is given by the polynomial 2 pi r squared plus 2 pi rh, where the radius is r and the height is h. It says factor this expression, period. I'm going to put a period there. So, we want to factor 2 pi r squared plus 2 pi rh. What will be the GCF? And then what will be left over? GCF is what? 2 pi r, and then what is left? R plus h.